Hey, Jared, thanks for being on the interview today.
Yeah, man, no problem.
Cool. Just to start off, can you tell us a little bit about yourself?
Yeah, Jared Haywood. I work at Big Squid as a data scientist, currently on our client services side of the organization. Um, I run a meetup called the Utah Deep Learning Meetup, which is kind of focused clearly on deep learning,
Yeah.
which is, for some people who don't know, kind of a subset of machine learning. It's using specific approaches to solving problems. So it's commonly used for things like image recognition, etc., which is not something we do at Big Squid. So that gives me a good opportunity to have a wide variety of things in the data science industry at the moment.
Yeah. How did you get into data science?
So my background is a little bit less conventional than you might find in a lot of other data scientists. It's becoming more normal. Just that I don't have the formal PhD education that a lot of data scientists might have. My background is actually kind of long-winded. So to save you that pain, I have a minor in chemistry and a bachelor's in business management, and then have done an internship with a deep learning as a service company and just a number of courses through Coursera, edX, Udacity, to be able to kind of get the experiential credentials that I need to do what I'm doing today. But ultimately, the way that I look at it, everything that I've done has always been applied mathematics.
Awesome. So it sounds like you're very much self-taught.
Yeah, I mean, to say self-taught is maybe a little bit of a stretch. I don't think that I'd be here without the help and guidance of people who do have those formal credentials.
Uh-huh.
But yeah, and I think that we're seeing that become a little bit more of the norm, with especially as some of these different online formats get more credentials and more companies backing them. Specifically, Udacity has done a wonderful job in the deep learning space with partnering with Google and other platforms in order to kind of get the backing that they need to say, hey, yeah, this is legit education. If you pass this course, then you're certified. You get this certificate that says, hey, yeah, you can do this. And I think they have pretty good job placement for that as well. So that's kind of cool how the industry is changing just based on the increase in demand.
Yeah, and I think this wasn't one of the original discussion topics, but what's your opinion on the rise of the citizen data scientist?
I don't think that I think it's very rare that there's going to be. Well, let's put it this way: I don't think it's going to be these citizen data scientists or these non-formally educated data scientists that make major technological breakthroughs, that create a brand new algorithm. I think that is going to still be those PhDs who are focused on research and trying new things. I think that though that these people have the ability and capacity to apply the algorithms that are already there. I think they have the ability to know where to apply them and to get value. And I think that we can say that partially because, the math for something like linear regression was created hundreds of years ago. And so here we are today. A lot of people can do linear regression, even in something like Excel, right?
Yeah. And as you've been working with Big Squid clients and helping them implement the Kraken software, what are some of the commonalities that you've seen of customers and clients that are really successful with machine learning when they've never done machine learning before?
I think really one of the first things, and my answer might change day to day depending on when you ask me, right? But I think that one of the things that comes to mind is just having the right expectations. Coming in with the wrong expectations is always going to cause some friction and prevent things from running smoothly, and even the ability to run with it into the final solution, which is where you end up getting value out of it. Anything that really stops you from kind of that final step of creating an actionable solution from that project, and in this case, I would say disillusionment or just having unmet expectations. Mm-hmm. So, which is caused by having incorrect or fallacious expectations, ends up yielding higher likelihood for an unsuccessful client.
And what are some of the expectations that are good, and what are some of the expectations that are maybe a little bit misguided?
Yeah, so I think that misguided expectations generally come from just not knowing the strengths and weaknesses of machine learning. Not understanding that anytime that you have to run another math problem, like really you have to ask another machine learning question. And let me go into that a little bit. So let's say you're a subscription company. On day 0, somebody signs up for a subscription. Well, obviously every subscription company is going to have some churn, right? But there's different ways to calculate that churn. So is it that they cancel their subscription in 6 months? Is it that they cancel in a year? Like what is it that we're actually calculating for churn? And most of these subscription companies will calculate that churn at different time periods. So what is 30-day churn, 90-day churn, 6-month churn, 1-year churn? And depending on what the subscription is, right? It could vary. But ultimately, each one of those is a different machine learning question. The same way that you have to add up active subscribers at a year and divide it by the original initial subscribers at a year, mm-hmm. like that's one calculation. You have to make that same calculation at 6 months, 90 days, 30 days. Yeah. And people think that machine learning should be able to answer all of those at once with mm-hmm. a single model. But really, for each one of those to be able to predict the individuals at an individual granular level, you really, to be able to do it the most accurately and have the best interpretability, you want a model for each one of those times that you're having to run that calculation. Yeah. And so people kind of just think, they see it as a big stick, and in some aspects it is, but not in the aspect that it can hit multiple times with one swing, if that makes sense.
Yeah. I once heard a joke that when people think of ML, they think that the M stands for magic.
Yeah.
As it turns out, it's machine.
The second thing I would say is people have this expectation. They expect it to garnish brand new, glorious insight that will change their strategy at a very high level. Let's imagine that we're wanting to predict from 1 year of user activity. We want to predict the lifetime value of users after being users for 2 years. Well, one of the fun things about that is that your intuition would probably tell you it's going to be based on what they made in the first year, or what the lifetime value of that user was in the first year. Mm-hmm. And yeah, machine learning is probably going to say that too. So human intuition is often some of the most feature important drivers. And I guess the thing that I would say is people have this expectation that all of a sudden there's this brand new thing, that it surfaces as being really important. And ultimately, if it hasn't been surfaced in BI, if it hasn't been surfaced in general intuition and years of business domain knowledge, it's probably not going to surface as being super important in machine learning. place that machine learning does come in to be valuable is it can confirm those assumptions empirically and mathematically. But also, the thing that I would say is that the point of machine learning isn't necessarily to garnish new high-level strategies. Sometimes that is an outcome and something that you can do, but those high-level strategies aren't necessarily going to be because you found this brand new thing that's super important. Those high-level strategies are going to be because you're able to work at a more granular level. So specifically, let's say that I have an understanding of which of my customers, I generally know what might cause customer churn, right? It might be because of this or because of that. And for different businesses, it's going to be different things that cause customer churn. But ultimately, I guess one example that I've enjoyed, let's go the reverse way, is conversion. Say I have a mobile application. Studies everywhere show that iOS users are more likely to convert and pay money, make in-app purchases than Android users. Mm-hmm. And so I have an Android build and I have an iOS build. When it comes down to it, some Android users are going to be more likely to convert than some iOS users. And what machine learning allows me to do is it allows me to not make a base assumption and just say, oh, all Android users are worse than all iOS users. It allows me to blend and really differentiate and say, okay, these iOS users from here over, they are the users that I want, and it's these Android users that I want from here over. And so it allows me to make more specific decisions and be a little bit more tactical. And I would say the same thing like with emails. Rather than sending a blanket email, my high level strategy then becomes to be more targeted, more specific, rather than make blanket statements or blanket assumptions about marketing or ad spend or retargeting, etc. Yeah. It allows me to make very specific, targeted decisions that should yield a higher ROI, whether that's just because I am spending my time more efficiently or my money more efficiently, etc.
It's interesting that you say that by making micro changes, it's really that's going to influence the macro decision. Because a lot of times, I think in business we think, hey, we need to have a high level strategy, and then we're going to bring it down to the micro. But it sounds like in this case, it's opposite. We're going to impact the micro strategy, which is then going to impact the macro strategy.
Yeah, I think that's probably a fair way to look at that. And part of that is when you consider having a micro strategy like that, no human has the ability to go through and look through thousands and thousands of user data and say, okay, yeah, I mean, and sure, they might be able to make a decently educated guess at how likely that customer is to churn based on looking at some things. And a human would start to pick up on patterns. The problem and the reason and the place where machine learning makes it possible is that it's able to iterate through thousands of records and push out those predictions and make that very micro strategy feasible and feasibly automated, so that you're removing a human from the loop in making those very micro decisions.
Got it. Yeah, no, that makes a lot of sense, and that is really what we're seeing with a lot of our clients, as you know, is take someone like Singular. There's no way that they're going to go through all their customers and say, here's the ones that are going to be churning, but now they have an automated way that they can push out to the field and to the appropriate marketing people to say, this is the message that we should be targeting to these people. That was never possible before.
Right.
One thing that you were saying, I want to touch on again, which is with the Android example, it's kind of sounded like what you were saying to me is machine learning is really good for finding the edge cases. So you can make broad strokes and say all Android sucks and all iPhone's great. But really, it's more nuanced than that. And there are those edge cases that there's probably, let's call it 15% of Android users that you could be getting. You just don't know which 15% there are. And those are the people on the edge that, with the appropriate marketing message, could be tipped over to the good column. Just wanted your thoughts on that.
Yeah, so I think that's a little bit different than what I was saying, but I still think that's relevant. Ultimately, yeah, that's one of the strengths of using machine learning, and one of the things that I think successful clients do. I think successful clients recognize that machine learning can give you a probability of an outcome. And so let's say that it's gym membership, right? And I have all of my gym members, and I'm able to predict with some probability, say that it's retention. So the probability the gym member will be retained. If I have a really low percentage, that does mean, there is a probability that person stays, but ultimately, as a business, what I would be really cool and would increase my retention is if I focus on these people, maybe between this like 30 and 60%, knowing that the people 60% and above are just so likely that, I don't necessarily even need to interact with them.
Yeah.
Or let me rephrase that, do anything additional to what we're already doing in order to retain that user or that gym member. And so let me focus my efforts on these people between 30 and 60%, and I'm just going to ignore the people who are 0 to 30% likely. Just because, I want to maximize my efforts. And if I was to, let's say a gym decided to offer a single personal free trainer session in order to try and retain them, well, that means you're spending money. There's a cost to that, right? And you don't want to spend money to retain money that you're going to keep no matter what already, right? Then you're just reducing your profitability. And you don't want to spend money on something that is so low, that has such a low likelihood of generating more income. And so you spend that money where you're going to get a high ROI in pushing those people from maybe being 40% probabilistically to be retained to 60%. Yeah. And that's trying to take the results of machine learning and do something a little bit extra. And so from there, you could have an automated email that says, hey, if this machine learning output puts this person between X probability and X probability, then automatically trigger this email and send them this offer.
That's a really tactical and a really pragmatic way to use machine learning. So Jared, my last question is, if a company is looking to invest in machine learning, let's say they know they have a customer churn problem, but they've never used machine learning before, what do they need to be doing with their data right now to help them prepare for machine learning?
First, I want to say one more thing that unsuccessful clients do.
Okay.
Unsuccessful clients hunt the golden goose first. Every business has a problem that is their biggest, largest problem that there's a really low probability of actually solving. They don't know the answers, we don't know the answers, and sometimes that's just a social or economic thing that you're going to fight against the whole time of being a business. And so to try and solve that as your first machine learning use case, well, of course, we all wish that we could solve the golden goose, right? Yeah. I mean, the golden goose for machine learning would be if I could very accurately predict stock market, in which case I would not be working at Big Squid. So I think that's one of the challenges, and I think that does come with setting expectations, like having the proper expectations that we're going to fix little things that roll up into making a big difference.
Right. What are some considerations, or what are some things that people can do with their data now if they want to start investing in machine learning, let's say in 3 to 6 months?
There's two things. Good BI is really important. Good BI has the ability to track change. So by tracking change, you need historical or transactional or event data. Yeah, so if you're not recording historical snapshots of your data, and in some instances that's handled manually or naturally, I guess I should say, through something like transactions. Every time a customer makes a new purchase, it gets a record, right? And so you're able to see these trends, and you see what happened 3 months ago, and you're still able to see what's happening today. In some instances, that's not the case. In some instances, companies are just updating a single record, and they continue to update that record, and it's considered live data, and it's fit their business use case of what they've needed for their engine or machine or business to work. But that doesn't fit good BI, which also means it doesn't fit good ML predictive, ML diagnostic or ML predictive or ML prescriptive type data needs. So I think that's the biggest thing that I would recommend, is making sure that they're able to compare what happened yesterday to what's happening today.
That's a really good tip. All right, Jared, I know we're out of time. I appreciate it, and we'll talk soon.
Awesome. Thanks, Zach.
Thanks. Bye.